So this video is going to go into the quantum mechanical model that we now believe to be true of how the atom is set up. But before we get into that, I've been using a term called valence electrons a couple times, and I just want to make sure we formally have it in our notes. So valence electrons are the electrons in the highest or outermost energy level. And this is a term we're going to be using, especially on our next unit when we go more in depth into the electron. But valence electrons is definitely a term that you're going to need to be familiar with. So in your notes, put quantum mechanical model. So this is, again, the process we have gone through in terms of history is where we are now. So this is a list essentially of maybe the history that we've been talking about all along. So again, we had Dalton, we talked about J.J. Thomson, Rutherford, Johnson. J.J. Thomson was, again, the plum pudding model, and his discovery using the cathode ray. We talked about Rutherford was the gold foil, so he figured out that there was a positive center in the middle of the atom, essentially, and most of it was empty space. So we've been talking about the planetary model, Bohr's model, to kind of understand the different trends we've been talking about. And again, it's a good representation of these energy levels. He was correct about that. But now we have the quantum model and a scientist called Schrodinger, who him and a number of other scientists came up with a math model to predict where these electrons would be located. So essentially it has stopped what we call the Bohr model. So that's no longer true. So this is based on math. Again, you don't need to know it's called Schrodinger's equation, but maybe that is helpful to you to know exactly who we're talking about here. So electrons do not have paths or orbits, so that is where Bohr's model is incorrect. We now believe the electron to be in what we call electron clouds. And all I want you to imagine with that is it's a three-dimensional space around the nucleus, So again, they are not orbiting like Bohr thought, they are actually in a space around the nucleus. And we do know that the electrons live in what we call these energy states, and that was correct in terms of Bohr. What he was incorrect about is they are not equally spaced, but we'll get into that a little bit later on. But these electrons do have different energy states that they exist in. So in your notes, draw what we call the model, the quantum model. And again, please indicate that this is a sphere, not a circle. So please put sphere in your notes and put 3 dimensions, just so you understand that it is, again, the area around the nucleus, not just a circle in that. Draw an electron, an E, and negative, and then show that it's going in all directions, because that is true. And you have a little nucleus in the middle. And the math predicts that about 90% probability of finding that electron in this space. So 90%, you might think is not that good, but really for finding something so small and something moving so fast as the electron does, that's a pretty good probability of finding it there. So again, these clouds are going to be what we talk about. And we don't call them clouds necessarily, we call them orbitals. Okay, so we're going to call them atomic orbitals is going to be a term that you're going to hear. So again, don't want to confuse you, but there are definitely terms that we're going to be focusing on. So these clouds have different shapes associated with them. And again, it's all based off of math probability of finding that electron, okay? So that probability is that electron is somewhere in the space that I'm about to show you, okay? So these are called orbitals. They're called orbitals. And each one of them have letters associated with it. So we are going to be talking about orbitals called S, P, D, and F. Maybe in your lifetime, they will get to elements that actually fill up the next orbital. So a good trivia question would be a G orbital. We don't have elements that fill the G orbital quite yet, but maybe in your lifetime you will see that. But we are just going to be dealing with these atomic orbitals. And these letters are associated with mass, not with the shape itself, meaning S is going to be a particular shape, but that's not where the S comes from. It comes from sharp. So it has to do with the math involved. So I'm going to give you some notes on each one of them, and I'm going to show you a couple graphical images so you could kind of get an idea. So we only have an S orbital. There's only one of them because it's just a sphere. And again, S doesn't stand for sphere, but that's a good way to remember it if that is something that will help you. P orbitals are what we call dumbbell shapes, and we have 3 of them, and you will see why in a second when I show it to you. There are 5 d orbitals and there are 7 f orbitals. So the key numbers are 1, 3, 5, and 7. 1, 3, 5, and 7. So 1 s orbital, we have 3 p orbitals, we have 5 d orbitals, and 7 f orbitals. Okay. So I have a link up on the slide to this, but this is called the Orbitron. This is an example of what they would do graphically for showing an s orbital. So an s orbital is a sphere. It's over the x, the y, and the z axis. So this is just doing a cross section of a s orbital. So again, spheres are pretty easy to see or imagine in your head. A p orbital looks a little different. It's what we call a dumbbell shape, or a figure 8 is another way to do it. Now, depending upon the website you get this from, sometimes they show, they don't show up very nicely, or they do different colors just to show dimensions. So just because it's white and yellow doesn't mean anything different, but please recognize that sometimes it's on the z-axis, sometimes it's on the y, and sometimes it's on the x. And that is why we could have 3 different p orbitals because of that fact. So because I have 3 different dimensions I could go off of. Then we have the d orbitals. Now these, I don't expect you to know any of the shapes because they do get a little funky. So this is one d orbital, but then you have these d orbitals, which have essentially 4 lobes. And again, what this is trying to show is where they are predicting the electron to be. So if they're in a d orbital, they're somewhere in these lobes, depending upon which d orbital they happen to be in. And finally, we have an f orbital, even more funky, okay? And again, these f orbitals are a little bit strange, and again, never going to be asked to draw them. So these are what they are predicting the g orbitals to look like in the future. So again, these are just subject to math calculations in order to figure out where they would actually go. Now, in this website, if I go back a little bit, they also do what they call the dot or dot density for each one of these. And so let me see if it pulls it up. So the dots here are signifying that is more often than not where the electron is located. So it's a way for them to essentially sense or predict where that electron is going to be. So you will see darker dots in the middle and then fewer dots as you go outside of it. So again, this is why they are representing the s orbital as essentially a sphere, because of the fact that you can predict 90% of the time those dots are going to be in that sphere. Where it gets a little more weird to find is the p orbital. Again, you could then predict that electron is somewhere in that space, okay, either on the x or the y or the z axis. So that's just a way to kind of represent what the orbital looks like. So all we're trying to do is look for the electron. That's what we are trying to do. So each one of these orbitals are going to have different energy states and different orbitals within them. So if you would put into your notes energy level, make a little column for energy level, and then put shape / orbital, okay, however way you're going to know what that means. So energy levels are going to have different orbitals, and that's kind of what that website was trying to show you. So the first energy state is only going to have an s orbital. And the first energy level is the closest to the nucleus. So energy level 1 is where we start with the electrons and then we move out. So again, the Bohr model is not correct, but it is a good visual for you to understand exactly. We have more and more circles, so that is more and more energy levels outside the nucleus. Energy level 2 is s and p orbitals. Those again are in the second circle, if you think of it. So it is further out than the first energy state. So now we have spheres and we have those dumbbell shapes. Third would be sp and d orbitals. Again, they would all be outside that second energy state, so they'd be in the third energy state. And then fourth energy state would be sp, d, and f, and that's where we stop, essentially, with adding new orbitals. But realize that we have 3 other energy states. We have energy state 5, 6, and 7. And they all have sp, d, and f orbitals. We, again, don't know where the g is going to go yet, or they might know, I just don't know myself. So these are going to be, again, the repeating pattern over and over again. So again, the number is going to signify the energy level. The letter is going to signify what the shape is, okay? And this is going to be a pattern that we talk about. So in my next video, you are going to learn about what we call electron configuration using the block system, And all electron configuration is a way for us to shorthand writing out exactly where all of the electrons are located. So they, again, start with energy level 1 and you work yourself out. So the electron configuration is a way for chemists to know exactly where the electrons are, especially the valence electrons. So we care about the outermost electrons more than the inner ones. So electron configuration is a nice way to kind of summarize that. So in the next video is where you're going to see me do electron configuration, okay, using the block system. And that's where you're going to learn how to do that. Okay, so that's the summary of the quantum model.